Now we are going to solve some problems which are based on integration by parts and Lie rule. So the first problem is to solve integration of x into sin x dx. So here if we use Lie rule, that is, here we have algebraic and trigonometric functions. So according to this, algebraic is first function and trigonometry is second function. So here u is equal to x and v is equal to sin x. So according to integration by parts, that is integration of u into sin x dx. U as first function, that is x into sin x, x as first function. Integration of v, that is integration of sin x dx, minus integration whole derivative of first function into integration of second function or whole integration. So here we get x into integration of sin x is minus cos x, minus in derivative of x is 1, integration of sin x is minus cos x whole dx. 1 into minus cos x is plus cos x dx. So now what is the integration of cos x dx? It is very easy. Here just we have to choose first and second function. So what is the integration of cos x? Integration of cos x is sin x plus constant of integration c. So this is the integration of x into sin x dx. So the next problem, that is to find integration of log of x dx. So while discussing Lie rule, we also discussed that if we have log x or inverse trigonometry or trigonometry as function, so we have to find their functions by taking one as a product function with the log x. So we can write integral log x dx is equal to integral of log x into 1 into dx. So according to Lie rule, this is the first function and algebraic function is the second function. So here u is equal to log x and v is equal to 1. Therefore, integration of log x into 1 dx is equal to first function as it is, integration of second function, that is integration of 1 dx minus integration of derivative of log x into integration of 1 dx whole integration. So we get here log x into integration of 1 is x minus derivative of log x is 1 by x and integration of 1 is x whole integration over the x. So we get log x into x minus 1 dx. X is cancelled out by x. So we get x into log x minus x plus c. That is the integration of log x dx. Now we are going to solve the third problem. That is, we have to find the integration of x square into e raised to power 5x dx. So according to Lie rule, a as first function and e as second function. So here u is equal to x square and v is equal to e raised to power 5x. So according to product rule of integration. Integration of x square into e raised to power 5x dx is equal to first function as this into integration of second function minus integration derivative of first function into integration of second function over the whole integration. So here we get x square into e raised to power 5x over 5, that is the integration rule, that is e raised to 5x over derivative of function, that is derivative of 5x. Derivative of 5x is 5 minus derivative of x square is 2x into integration of e raised to power 5x over 5 whole integration dx. So if we say here, we have to again use the product rule. That is, we get x square into e raised to power 5x over 5 minus 2 over 5 we can take out. We have to find out the integration x into e raised to power x dx. Again product rule. So here this is the first function and this is the second function again. So we are using again product rule or integration by parts. Therefore, integration of x raised to power 2 x square into e raised to power 5x dx is equal to x square into e raised to power 5x over 5 minus 2 over 5, and we have to use again product rule. First function as it is, integration of second function minus integration of derivative of first function, derivative of x is 1 and integration of e raised to power 5x is e raised to power 5x over 5 into dx. So from here we get x square into e raised to power 5x over 5 minus 2 by 5 x into e raised to power 5x is e raised to power 5x over 5 minus again integration 1 by 5 is out, e raised to power 5x integration is e raised to power 5x over 5 plus c. So here we get x square into e raised to power 5x over 5 minus 2 over 25 into x into e raised to power 5x plus 2 over 125 e raised to power 5x plus c. So this is the integration of x square into e raised to power 5x dx. So sometimes you see in the question we have to use again and again product rule. Now the next problem is problem number 4. We have to find integration of x into sine inverse x over under root 1 minus x square dx for every x lying between 0 and 1. Because if x is equal to 1, function becomes infinity. So if we see here and we remind our rule of substitution used in indefinite integral in semester 3rd, we can see that if the function is sine inverse x, then 1 upon under root 1 minus x square is its derivative. So to make the function easy, let sine inverse x is equal to t. So it gives x is equal to sine t and derivative of it is 1 over under root 1 minus x square dx is equal to dt. So again we can replace these three quantities in this integral factor, that is x becomes sine t and sine inverse x becomes t and 1 over under root 1 minus x square dx is dt. So we get very simple form of this integral, that is denoted by I. So we denote the above integral as I. So we get this. So now we have to find the integration of these two functions, product of these two functions. So if we see, by Lie rule, this is a trigonometric function and algebraic function. So we have to take this function as first and this function as second. So here u is equal to t and v is equal to sin t. Now we have to find the integral of these functions. So first function as it is, integration of second function minus integral derivative of first function, derivative of t with respect to t is 1 into integration of sin t is minus cos t over the whole integration. So the next step is t into integration of sin t, that is minus cos t. Here minus minus become plus and integration of cos t dt. So we get here minus t into cos t, again integration of cos t is sin t plus c. So if we see here, t can be replaced by again sin inverse, sin t is replaced by x. What about cos t? We have to convert cos into sin form, that is 1 minus sin square t, to get our answer in x form, x variable. So t is replaced by x and sin t is replaced by, that is t is replaced by sin inverse x and sin t is replaced by x, that is x square, and sin t is again replaced by x. So we get the required answer is our minus sin x under root 1 minus x square plus x plus c. So this is the integration of x into sin inverse x over under root 1 minus x square dx. So if you see in some question, first of all we have to make our integration by using substitution method to convert typical integral into simple form. Now we are going to solve the next problem, that is fifth. We have to solve e raised to power x into cos x dx. So if you remember, while discussing Lie rule, we said we can violate this rule. According to Lie rule, this is as first function and e as second function. So if we take u as cos x and v as e raised to power x, then we have to find the integration of this function, that is e raised to power x cos x dx. Cos it is as I. Then this is equal to first function as it is, that is cos x is as it is, integration of second function minus integration whole, derivative of cos is minus sin x into integration of ex is ex whole dx. So if we see here, we have to use again the product rule in this part. Integration of e raised to power x is e raised to power x, minus minus become plus. So if we see here, we get sin x into e raised to power x dx. So here sin x is first function and e raised to power x as second function. So if we see here, we have to again do product rule. So first function as it is, integration of second function minus integration of whole function, that is derivative of sin x is cos x and integration of ex is e raised to power x dx. So if we see here, we have I is equal to cos x into e raised to power x plus sin x into e raised to power x. While doing this, when we are getting again I, we have to introduce plus integration sign because we are not doing another step to do this integration. So when such type of case occur, we have to introduce I while retaining same while retaining same type of given integral. The integration of e raised to power x is e raised to power x. This is minus I plus c. So while retaining this form as I, we have to introduce c. So here we get 2i is equal to e raised to power x as common. We get cos x plus sin x plus c. So here we get I is equal to e raised to power x over 2 cos x plus sin x plus c by 2. That is replaced by c dash, that is a constant. So integration of e raised to power x cos x is e raised to power x over 2 cos x plus sin x plus c dash, where c dash is constant, that is c by 2. Now what happened when we violate the rule? So let's see. By violate the rule, what is the result of this integration? So we have e raised to power x into cos x, that is taken as I space again, or you can say I1. We say I1 by using u is equal to e raised to power x and v is equal to cos x, that is while according to rule we have to take u is equal to cos and v is equal to ex. But now here we are taking a u is equal to e raised to power x and v is equal to cos x, and we given our integral name as I1. So I1 is equal to first function as it is, integration of second function minus derivative of first function, derivative e raised to power x is e raised to power x, and integration of cos x is sin x dx. So we get again the product rule here. So integration of cos x is sin x minus we have to again do the product rule. First function as it is, we are again taking ex as first function, integration of second function minus integral of whole function ex, derivative ex is ex, integration of sin x is minus cos x dx. Now we get e raised to power x sin x minus e raised to power x, integration of sin x is minus cos x, minus minus plus, and it becomes e raised to power x cos x dx. So it is again I1. So we get I1 is equal to e raised to power x sin x minus minus plus e raised to power x cos x. As we are giving it name as I1, we have to introduce constant of integration. So from here we get 2 times of I1 is equal to e raised to power x as common, sin x plus cos x plus c. So I1 is equal to e raised to power x over 2 cos x plus sin x plus c over 2. So we replace c by 2 by c dash, where c dash is equal to c by 2, constant of integration. So if we see here, we get the same result as I. So we get I1 is equal to I. That means by violating the rule, in the case of ET form, there is no change in the result. So in the ET form, there is no force to take E as first function and T as second function. So it is our choice. So it was all about the sum problem which are based on integration by parts. So you can practice more questions to become familiar with the integration of parts rule.